So next is chapter 11, that is vectors. Most of the topics are from O levels. Use vectors in 2 dimensions, column vectors, and carry out arithmetic operations, just simple addition, subtraction, calculate the magnitude, Pythagoras theorem. Direction of vector is basically the gradient. Understand the use of position vectors, OA, OB. Use vectors to solve geometric problems. We'll see what we have. Understand vectors magnitude and use vectors in speed and distance calculations. Use vectors to solve problems in the context, whatever problems are given. So let's see. Prior knowledge, obviously this is a translation vector, sort of translation vector, right? The column vector for the translation of shape A to B. So if it is moving from A to B, we can say that this movement is 1, 2, 3, 4 boxes to right and 2 boxes upwards. So I can say this is 4, 2. A to C. If I look at A to C, this is again 1, 2, 3, 4, 5. 5 boxes to right and 1, 2. 2 boxes below. So it is 5 minus 2. Upwards is positive, right is positive, downwards is negative, and left is negative. Next knowledge, P provides the line AB in ratio 7:2. So we know this is 7 and this is 2. So find AP. We can just copy the values from the given information. AP is 7, AB is 9. Then PB is 2 and AB is again 9. AP is 7 and PB is 2. Find X to 1 decimal place. Now again, this is trigonometry, cosine rule. So what was that? That is 9 square is equals to 3 square plus 7 square minus 2 into 3 into 7 into cos of x. Vectors basics. Vectors has both magnitude and direction. Magnitude is basically the length and direction the angle at which it is. So if we look at PQ, it is from P to Q, and QP is basically negative of that. I can say PQ is equals to negative QP. As if we call AB as with A and BA is opposite of that, so it is negative A. Triangle law, addition and subtraction. Where do you start? We start from A to B, then from B to C, and we end at C. So from S to E, this is start, that is end. And this is the resultant vector. Normally it is labeled with 2 dots. And next is another example. The diagram shows vectors A, B and C. Draw a diagram to illustrate the vectors. This is on the right, this is A, B and C. If we have to draw this A plus B plus C, this could be in any order, it makes no difference. He's first drawn A. I'll write A first. If I have to write it in column vectors, we can see this is 1, 2, 3, 4, 5, 6. 6A, X and 3Y. So we can say A is 6, 3. Same case B, we can write B is 3 minus 2. So 3 minus 2, and C is, there's no movement in X, so that is 0. And in case of Y, 1, 2, 3, 4, 5, it comes 5 units downwards. So this is ABC. You start with any vector, the resultant is always same. Suppose he is already drawn A plus B plus C. Let's do C plus B plus A. So first, if I draw C, suppose I start from here and I know that it is 0 minus 5. So 1, 2, 3, 4, 5. 5 units down, this comes right here. This is C. Then I add B in it. B, I know it is 6, 3. So moving 6 units to right, 1, 2, 3, 4, 5, 6. 6 units right and 3 units upwards. So I come over here. This is C plus B. Then again C plus B, another addition of A. What did I just do? This is C plus A. I did C plus A, now I'm doing B. B is 3 minus 2. So X is 1, 2, 3 and minus 2. So it comes here. Now I know that I started at this point and ended at this point. So drawing my resultant is, we start from here and we end it here. If I need to count this, this is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 in X and 1, 2, 3, 4. So basically the resultant is 10 minus 4. If you look at the already drawn resultant, this was, there's a slight mistake in B, let me correct that. The last, it was 3 minus 2, I draw 4 minus 2, 1, 2, 3, 3 minus 2 is this. So this is the resultant and it is 9 minus 4. So if you count for this, this is 1, 2, 3, 4 and 1, 2, 3, 4, 5, 6, 7, 8, 9. Both are 9 minus 4. The other way we can do it is solving with the column vectors. You see, we have already written it in column vector form, A, B and C. Right here, this is A, B and C. When the question tells you to solve for A plus B plus C, so we can add these columns directly. 6, 3 plus 3 minus 2 plus 0 minus 5. So if we add these, 6 plus 3 is 9. 3 minus 2 is 1. 1 minus 5 is minus 4. So this is 9 minus 4. So you start from anywhere, move 9 units to right, 1, 2, 3, 4, 5, 6, 7, 8, 9 and 4 units downwards. So this is 1, 2, 3, 4 units downwards. So this is your resultant, which is A plus B plus C. Subtracting is similar to addition, but just in the opposite direction. If we know this is A and B, A minus B, A stays as it is, B minus B would be parallel to this but in the opposite direction. So this is minus B, A minus B. This is your starting point, this is your ending point. So that is your resultant. Now adding vectors PQ plus QP, obviously it is going from P to Q, then again coming back from Q to P is a zero vector. It started from that point and it is again ending at the same point. Now what you are looking at is known as scalar multiple. If you already have A and someone tells you to write 2A, so actually you draw this A 2 times. This is 1 and this is again 2. So the length becomes 2 times, but it is parallel to the actual vector. So 3A is exactly parallel to A but 3 times in length. Half A is parallel to A but half that of length in case of magnitude. In this question it says find PS. So we start from P and we end at S. This is P, this is my starting point, this is S, this is my ending point. So when I start from P, I can see this path which is PQ plus QS. So for PS I can say it is PQ plus QS, and from the diagram I see that PQ is actually moving opposite to A, so we copy negative A. From Q to S it is moving in the same direction, so we copy C as it is. So either you leave it or you rearrange and take the negative number on the other side. Normally negative numbers are written afterwards. Simple parallelogram, head to tail rule, or just shifting the vectors. We know that AD is parallel to BC because this is a parallelogram, so I can write B here. Actually AD is equal to BC in all aspects, and AB is A, so we know that DA is also A. So if you need to find the resultant AC, either you go from the right side or you move from left side. Suppose I choose this path, so this would be A plus B. If I choose this path, this would be B plus A. Both start from the same point and end at the same point. Yes, yes, yes. That's why I'm just skipping it. It is just a quick revision. If we directly jump onto this question, and let's say I ask you for AG. So we know AG could be AC plus CB. Now AC is BB, and this is D and D again. Please excuse me. Just close this door. Okay, so from starting from A and ending at D, we moved through two B's and two D's. So AG is basically 2B plus 2D. Let us find something interesting. Representing vectors, column vectors, we covered it indirectly. To multiply a column vector by scalar, multiple each component by this. What does this mean? If you have like 3, 2 and you multiply it with 2, this becomes 6 and 4. So these are basically the scalar multiples, this 2 and this 3. Now what was I and J? I is basically the x direction and J is the y direction. Draw the diagram to represent minus 3i plus j. Minus 3i because it is the x direction, so from wherever you start you move 3 units to left, and j is the y direction and is positive, you move 1 unit upwards. So this is basically 3 1. If the examiner asks you about the direction, we know the gradient. If he asks you about the magnitude, this would be 3 square plus 1 square whole under the root, which would result in square root 10. So we can always convert the IJK form into column vector form. If it says that A is equals to 2i plus 5j, you can write A is equals to 2, 5 in column vector form. Okay. The vectors are drawn on the grid of unit squares. Express vector v 1 2 3 4 5 6 in IJ notation and column vector. So let's do 2 2 3 v1. We can see v1, there's no movement in y direction. This is purely horizontal and it is 1 2 3 4 5 6 7 8 units. So for v1 I can say it is 8i plus nothing because there's no j or 0j. You actually don't have to write this. So this is 8i, and in form of column vector v1 is 8 0. Let's see v2. So if you count from start till end, first the x part, that is 3 3 6 3 9 and 3. So this is 9i positive x-axis and 3j upwards, and in form of column vector this will become 9 3. Given that A is given, B is given, so simple scalar multiples and additions. Question number 4. Given that A is equals to 2i plus 5j and B is equals to 3i minus j, find lambda if A plus lambda B is parallel to vector I. Now see A plus lambda B. Whatever A is, I am just copying those values. A plus lambda B. A was 2i plus 5j lambda and B is 3i minus j. If we simplify this first, this becomes 2i plus 3 lambda I plus 5j minus lambda j. Now it says that it is parallel to ij. It is parallel to, oh sorry, that's question 5. It is parallel to vector I. If it is parallel to vector I, that actually means it is horizontal. It is parallel to vector I, that means it is horizontal. Being horizontal, that would mean the j part is 0. So we will equate this j part to 0. 5j minus lambda j is equals to 0j. So taking out common, the coefficient of j must be 0. So lambda is equals to 5. So solving for lambda, lambda is 5. Did you get this part? You can do that directly. That was just the first example. You can do that. You can do that. This was just the first example. Like if now you know this. No, that's not necessary. Now you know this, so look at this question, how we actually do it. This is mu into A and it is parallel to J. If it is parallel to J, I know that the I part would be 0. If it is parallel to J. So we just first copy it and we know that mu times A is 2I plus 5J plus B, that is 3I minus J. It is parallel to j, so I part is 0. I'm just copying I part in the next part, which is 2 mu plus 3 into I, and this is actually equal to 0. So when it is equal to 0, here you go, 2 mu plus 3 is equals to 0, mu is equals to negative 3 by 2, question finished. And so on. In triangle AB, AB is 4I plus 3J, AC is 5I plus 2J. It says find BC, so we start from B and we end at C. So BC is this plus this. Don't forget that AB is given and AC is given. So when we come from B to A, the signs they change, they reverse. So this is minus 4I minus 3J plus 5I plus 2J. So I with I, we're left with single I and minus J. So I minus J. B, C is I minus J. Okay, ratio part. Question 7 says OABC is parallelogram. P divides AC in the ratio 3:2. P divides AC in ratio 3:2. OA is given, which is 2I plus 4J. OC is given 7I. Find IJ format and the column vector format for AC. So we start from A, we end at C. We know that we are going in the reverse direction, so the signs of 2I and 4J will change. So this is minus 2I minus 4J and plus 7I. So simplifying, this is 5I minus 4J, and in column vector form this becomes 4, 5 minus 4. For OP, this is OP. Let me write for OP that OP is equals to OA plus AP. OA plus AP. Now we have actually solved for AC. The OA is already given in the question, and for AP, may I write it is 3 by 5 of AC? Any issues with this fraction? 3 by 5 of AC. No issue. So OP is 2I plus 4J plus 3 by 5, and AC we've already done that, which is 5i minus 4j, and we just simplify and add the I part to I and j part to j. Any confusion? Okay, let's see what do we have. Magnitude and direction, these are the simple things. Magnitude is straight away Pythagoras theorem. If you have A is equals to 3i plus 4j, magnitude of A would be 3 square plus 4 square whole square root 9, 16 square root 25, and that's 5. Magnitude and direction is basically the angle. And what is a unit vector? Whatever the magnitude is, you divide the vector with magnitude. For example, we considered 3 plus 4j and the magnitude is 5. So unit vector in the direction of A, that is vector divided by magnitude of A, and vector was 3i plus 4j divided by 5. This form is acceptable. 1 by 5 into 3i plus 4j is also acceptable. Third, 3 by 5i plus 4 by 5j, all three forms are acceptable. There was no example for direction, we would encounter them later, but let me explain it here. For example, you have this grid and we know that this was 3i and 4j. So 3 units in x direction and 4 units in y direction. So this is basically the direction. So direction is the gradient, so which is y over x. Gradient is 4 by 3. A is in this direction and having a magnitude of 5 units. Or we can also say that 3i plus 4j is the direction, because we know this is 3 in x direction positive and 4 in y direction, and in this way you draw the length which is actually equal to 5 units. Okay, in form of angle. Now you know that this is 4i and 5j, so using tan theta is perpendicular over base. Tan theta is actually equal to gradient. So theta is tan inverse of 5 by 4, and when you get the angle 51.3 degrees, either you show them with the diagram that this is the direction as shown with the horizontal, or you state that it is this much axis with the horizontal line. You have to clear it. Just like this diagram, when you write 30 degrees or 60 degrees only and there's no diagram, you just say that it is at 30 degrees. So you actually have to make it clear it is 30 degrees with the horizontal or it is 30 degrees with the vertical. Best and easiest way is to sketch a diagram. This question says find the magnitude of each of the vectors. So let's see, both of these values are negative. This is x is negative 4 and y is negative 1. So this is 4 and this is 1. So 4 and 1. If we find this angle, this is tan theta is equals to perpendicular over base. So tan theta is equals to tan inverse 1 by 4, and the angle would be battery issue. So whatever this angle would be, one way is either we sketch this diagram as you can see, and the other way is you answer it in the form of bearing. Can you please tell me this answer, tan inverse of 1 by 4? Yes. Shift 10.25. It just worked it. That is 14 degrees. Yeah, I think something's happened with this battery. I've just adjusted it. So that is 14 degrees. Either you draw the diagram and show that it is 14 degrees, or you write the statement that it is 14 degrees below negative x-axis. Two ways, or the third way could be 270 minus 14. I say that it is at a bearing of 256. Because just writing 14 would not make it clear that it is 14 in this direction or this direction or this direction. 14 degrees with which axis, with y or with x or any. So you have to be clear. Okay, now if we look at this, we will convert it into triangle and use sine cos tan to find the x and y directions. Yes. That's 4, 1 over 4. 1 over 4. Y divided by x. It is easy when you sketch. Tan theta is actually perpendicular divided by adjacent. If I just make a sketch without values, and this is theta, so this is always y and this is x. Yes, Mohammed. So no issues. In case you're doing this in exam and you solve it in radians, so definitely you would write RAD with your answer, so the examiner doesn't get confused. Now this is the question you're already given with the direction and magnitude, and he's asking you to write the vectors ij in ij form. So if this is 15, you have 45 and 45. So I'm using tan 45. I am using sine 45. So sine 45 is equals to perpendicular over hypotenuse. So solving for P would be 15 sine 45. So this is 15 times sine 45, and I get 10.6. I have a scratch. I actually need an exact answer. So if this is 15x and x, 15 square is equals to x square plus x square, 225 by 2 square root. Yes. I just skipped one step, solved it directly. 15 square is 225, and on the right hand side you have 2x square, and you bring this 2 on the other side. So this is basically x and y square root 225 by 2i plus square root 225 by 2j. In decimals it is 10 point something. Yes. In this case, yes, they are, because it is isosceles triangle. 45, 90, 45. This is isosceles triangle. So they are exactly same. For this, if we use cos of 20 is equals to base over hypotenuse, so 8 cos 20 is 7.5. So this is 7.5 I plus, solving for j, that is 8 squared minus 7.5 squared. I'm using Pythagoras theorem for j. Square root answer, we get 2.78, so that's 2.8 j, 7.5 I and 2.8 j. Getting the concept? Question number 8 gives the magnitude. This is 2 minus k. So magnitude is basically x square plus y square whole square root is equals to, magnitude is already given, 2 square root 10. So we take square root on both sides, square on both sides. So when you take square, this becomes 4 plus k square is equals to 4 times 10 is 40. So k square is equals to 40 minus 4. K square is equals to 36. Square root both sides. K is equals to plus minus 6. Getting it? Now see question number 9. Question number 9 says that vector A is Pi plus Qj. Pi plus Qj, both are unknown. It has a magnitude of 10. Magnitude of A is equals to 10. An angle theta with positive x-axis. So wherever it is with positive x-axis, this is theta. And we are given with sine theta is equals to 3 by 5. Find the possible values of P and Q. So P is unknown and Q is unknown. We know that sine theta is 3 by 5. So if we just sketch this, sine is perpendicular over hypotenuse. This is 3 by 5. Do not confuse this ratio with the actual magnitude. This is 3 by 5, and if I solve using Pythagoras theorem, the unknown comes out to be 4. So this unknown is 4. This is just a coincidence that this 10 is exactly 2 times this 5. So we know that the actual lengths would be 10, 6 and 8. This may not be the case every time, but yes, they are similar triangles. We can always solve them using similarity. So P and Q, may I say P is equals to 8 and Q is equals to 6? Any confusion in this part? Okay. And these are just questions with different statements. Do go through them if you find any confusion. Okay. Now this is position vector part. Position vector is everything we've been doing. If you are given with coordinates of A, B or C, so that is a actually their position. If you say A is equals to 2 comma 3 and you say B is equals to 9 comma minus 7, so when we sketch them, A would appear somewhere here 2 comma 3, and with the idea 9 is more to the right and minus 7 is more to the bottom, so this would look like this, AB. So this is actually the position of A and this is position of B. So OA is 2 3, or OA is 2I plus 3J. For B we can say OB is equals to 9 minus 7, or we can say OB is equals to 9I minus 7J. Position from O is known as position vector. And how do we represent them? If you say AB and it says that split them in position vectors, this is always this way, second minus first. If the question is PQ, this is always OQ minus OP. XY, this is always second minus first. So in case of AB, if we have to find AB, AB is OB minus OA. Now OB and OA are position vectors, so we just copy them. OB is 9 minus 7, minus A is 2 3, so we simplify. 9 minus 2 is 7, 7 minus 3 is minus 10. So actually AB would be 7I minus 10J. Yes, this is position vector, magnitude, direction. Okay, let's see what this is. It says these are three positions of a parallelogram. Let's have a rough sketch. One is 4 2, the other is 3 5, the last is 8 6. 4 2 3 5 8 6. If I roughly sketch them, x4 y2, then x3 and y5, last is x8 and y6. So if we consider that these are the three vertices of parallelogram as stated, the question demands the fourth vertex. Find the possible position vector of the fourth vertex. So we actually have two possibilities. One is that the fourth point would lie somewhere here. Let's solve this first one, then I'll do the second one. So this is x comma y. So we know if it is a parallelogram, this vector in green and this vector in green, they are parallel and equal in size. Yes, Mohammed. If that is the case, that's good. Yeah, sure. So if I'm finding this, I know this second point, I know this first point, so it was always second minus first. So 8 6 minus 3 5, I know that this is 5 1, so this vector would be actually 5 1. So when we add 5 1 to 4 2, we get xy. xy is equals to 4 2 plus 5 1. When we add these vectors, this become 5 4 9 2 1 3. This is 9 3. This is one of the possibility. The other possibility is we copy this diagram again. This is 4 2, this is 3 5, and this is 8 6. The other possibility is that you consider it moving this way, that the unknown point is here. This is xy. So we first again find this vector in blue, second minus first, 8 6 minus 4 2. So this is 4 4. Now we know that this vector is 4 comma 4. So xy would be initial point plus the translation vector 9. So the possible values are 9 comma 3 or 7 comma 9 for it to be a parallelogram. Okay, previous questions, these are more, I'll go back more. These questions, Mohammed. If you can pick one, we'll be able to. 9, sure. Question 9 tells you that A is a vector which is Pi plus Qj. Question 9 says A is a vector with Pi plus Qj, and there is some information given that magnitude is 10. So whatever this would be, this length would be 10. I'm just assuming that P and Q, if P and Q are positive, and it says angle theta with the positive x-axis, where, okay, angle theta with positive x-axis where sine theta is 3 by 5. So sine theta is equals to 3 by 5, and if I make this triangle, write theta here, this is 3, this is 5, perpendicular over hypotenuse. Applying Pythagoras theorem, we get this side as 4, and I said that luckily this was 2 times more than this 5. So this length would be 6 and this length would be 8. Agreed? If this wouldn't be the case, we'll write this like this. Within red, we know that this is just the ratio. So what we can do is we can solve for the unknown. We know this 5, we know this 10, we know this 3, with this 6 was unknown. So when you cross multiply, you get x is equals to 6. And the other possible value is if you draw it below the positive x-axis, and you consider this 5 and 3 again, so this would be in this direction, makes no change in x but in y. So the first possible value, that A is equals to Pi plus Qj, is 8i plus 6j. The second possible value is 8i minus 6j. जी मोहम्मद. Okay, position vectors, magnitudes, unit vectors, directions, and geometric problems. This is basically the ratios, the lengths. If we just consider this diagram, AP ratio PB, it says this is lambda, this is mu, unknown. So simple formula that if you have to solve for OP, follow the diagram and the algebra both. OP is OA plus AP, OA plus AP, and we know AP is AP is actually lambda by full lambda plus mu of AB. Let me write numbers that would be easy to understand. If this is 3:2, this is A, P, B. So I can write AP is 3 out of 5. So this was actually 3 and complete was 5. So unknown form 3 divided by complete length lambda plus mu 5. It is not necessary that you follow this structure. You can choose to write the numbers. Sorry? That is just the general formula. That is just the general formula. Okay, let me write it with numbers. No, the number would be given. If it is unknown, definitely we'll find them. For example, you are given with this. This is A, this is P, this is B, this is O, and these ratios are known as 3 and 2. So if I have to find OP, vectors are missing at this point. OP is OA plus AP. Any objections for OP? So whatever it would be, OA, there must be some vector. Till now it is not there. I can write OA plus 3 out of 5 of AB. Is it okay? In the question we just discussed that because the values were unknown, so we considered unknown variables, lambda and mu. So this is the only difference, that OP is equals to OA plus that was 3 by full, right? So now this is lambda by full of AB.